All right, so far, what you've been doing is taking equations, um, um, linear equations, or maybe tables of linear functions, and using those equations to plot some points, and then you just draw a straight line that connects all those points exactly. And that's what I would call it, a line of exact fit. And I would call it that because there's this there's this thing called a line of best fit, which is when you have data points that don't line up exactly in a perfectly straight line like you're used to. So a line of best fit is the line that most closely represents the basic trend um, in a data set, but it's not necessarily going to hit every single observation or data point that there is. This can be, an approximation, but as approximate, it's as close as it can get. It's the line of best fit. It's the best you can do in fitting it to all these, crazy data points that you have. Um, so this would be an example of a line of best fit. I've got all these data points that are they're sort of all over the map, but you can see they there's this kind of a trend here, right? They basically more or less kind of go like this. So my line of best fit shows that. And I get it. I try to hit as many of those points as I can. Um, right? So what it's used for is if you don't have an exact equation that defines a relationship, if you're just making observations, maybe you're doing some scientific observations, you're looking at I don't know, population of deer per size of their habitat. Maybe your X variable is how big their habitat is. Is it 100 square acres? Is it 1,000 acres squared? Maybe the size of their range or whatever their habitat is your X variable, and then your Y variable is you're actually counting or estimating how many deer are in that size of habitat. Well, you're going to plot those points, and it might not fit exactly a perfect line, but there might be a trend there. There might be a relationship there. It might be that the bigger the habitat, the more deer are there. There's a basic trend there. So you would plot all those points after actually literally observing um, values out in the field. You would observe as much as you can. You'd write down your data points. You'd plot it, and then in order to see a relationship, see if there really is a relationship or a correlation between the size of habitat and the number of deer present, you would plot those points, you'd visualize it, and then you draw a line of best fit. And then you could figure out an equation for the line of best fit, and that equation you could say is your best approximation of what the relationship is between habitat size and population size, something like that. So yeah, so it's a useful tool, but it is an approximation, and that's why it's called the line of best fit. All right,